Hello everyone, welcome back. In this lecture, we shall see the basic equations of heat transfer and the governing laws of conduction, convection and radiation. The first one is Fourier law of heat conduction. Fourier law of heat conduction states that the heat flow by conduction in any direction is proportional to the temperature gradient and area perpendicular to the flow direction. And it is always in the direction of negative gradient. It means heat flows from high temperature to low temperature. The mathematical formulation is given as Q is equal to minus K into A into dt by dx. Here dt by dx is the temperature gradient, that is change of temperature per unit width, and A is the normal area and K is the constant, that is called thermal conductivity of the material. It is a material property. We shall see the terms one by one. Q is nothing but the heat transfer rate and the unit is watt. When it is heat transfer rate, it means change in energy per unit time. So the unit is equivalent to power or watt. K is the thermal conductivity of the material. So higher the K value, higher will be the thermal conductivity. And the unit is watt per meter per Kelvin. A is the cross-sectional area of the body. And dt by dx is the temperature gradient along the direction of heat transfer. The unit is Kelvin per meter. Okay. We can also divide the heat transfer rate by area and call it as heat flux. It is represented by lower q, which is equal to minus k into dt by dx. This is the formula for heat conduction. Note that the negative sign indicates the heat flows from high temperature to low temperature here. Next we shall see thermal conductivity. Thermal conductivity K is a material property that determines its ability to conduct heat in that material. It is typically measured in watts per meter per Kelvin. Different materials have different thermal conductivities affecting their heat conduction capabilities. In metals, silver has the highest thermal conductivity, followed by copper and aluminum. And you can see the value of thermal conductivity in non-metals compared to metals. And gases have low thermal conductivity. For example, air has got the thermal conductivity of 0.024. So it means air is a poor conductor of heat. High thermal conductivity represents heat transfer happening quickly, example metals, and low thermal conductivity means heat transfer will happen slowly, that is in insulators. Next is convection. Convection is the heat transfer process through the fluid motion, that is in liquids or gases, and the heat transfer occurs between a fluid in motion and a bounding surface at a different temperature. As we have seen earlier, there are two types of convection, natural and forced convection, and inside forced convection, there are two categories, that is external and internal forced convection. So in the external convection, the flow goes around the solid body, and in internal convection, the flow goes inside the solid body, for example in a pipe flow. And there are combinations of internal and external convection also, where the flow goes both internal as well as external to the solid body. Next we shall see the Newton's law of cooling. The rate of convection heat transfer between a solid and fluid is given by Q is equal to H into A into Ts minus T infinity. Ts is the surface temperature and T infinity is the ambient temperature. We shall see the terms one by one. Q is the convective heat transfer rate and the unit is watt. H is the convective heat transfer coefficient. The unit is watt per meter square per Kelvin. A is the surface area where heat transfer happens, and Ts is the surface temperature and T infinity is the fluid temperature far from the surface. Here we can see in the figure, the heat transfer happens from the surface to the cold fluid passing above it. Okay. Here we can represent the heat flux, the lowercase q, as the heat transfer rate divided by area, so which is equal to H into Ts minus T infinity. Next we shall see about the convective heat transfer coefficient H. This is quite important. H, or the convective heat transfer coefficient, measures the effectiveness of heat transfer between a solid and fluid. Next we shall see about convective heat transfer coefficient. It is the measure of effectiveness of heat transfer between a solid surface and a fluid surrounding it. The influencing factors are fluid properties, flow conditions and surface roughness. The unit is watt per meter square per Kelvin. Some typical values of H are given here. For natural convection, the H value will be in the range of 3 to 20 for gases and 60 to 900 if it is water. And for forced convection, it will be higher. You can see the numbers here for gases, oils and water. And for boiling and condensation process, the value will be still higher in the range of 3000 to 100,000. Next is radiation. The expression is given through Stephen Boltzmann law. The radiation energy emitted by an object per unit time can be expressed as Q is equal to epsilon into sigma into area into T power 4 minus Ts power 4. We shall see the terms one by one. Q is the radiative heat transfer rate. The unit is watt. Epsilon is the emissivity of the material. It is a material property. It varies from 0 to 1. Next, sigma is the Stephen Boltzmann constant and the value is equal to 5.67 into 10 power minus 8 watt per meter square per Kelvin power 4. A is the surface area and T is the absolute temperature of the radiating surface and Ts is the absolute temperature of the surroundings. Here, emissivity epsilon is a measure of how effectively a material emits thermal radiation compared to a black body, and the range is 0 to 1. And radiation becomes dominant at high temperatures because the temperature is raised to power 4. Now let us come to the summary. The conduction is given by Fourier law where Q is equal to minus K into A into dt by dx. The convection heat transfer is described using Newton's law of cooling. Q is equal to H into A into Ts minus T infinity. And radiation is given by Stephen Boltzmann law where Q is equal to epsilon into sigma into A into T power 4 minus Ts power 4. Okay, in the next lectures we will see forced convection in detail and solve real world problems. Thank you.